All right, class 12, listen up. We're about to dive into what a lot of students think is one of the toughest topics in math, and we're going to turn it into your secret weapon for the board exams. Let's get right into it. So, what's the deal with the number 35? Well, in your CBSE Class 12 maths paper, 35 is the number of marks you get from just one unit, calculus. Yeah, that's right. That makes it, by far, the most critical part of your entire syllabus. And that's exactly what this is all about. This quote, it's our game plan. We're not just working hard, we're working smart, focusing on the topics that carry the most weight, so you can absolutely crush that exam. And if you need to see it to believe it, just look at this. Look at that chart. Calculus, with its 35 marks, takes up a massive chunk of the paper. It just completely overshadows everything else. This is where the real game is played, folks. Okay, so let's officially get this mission started. Over the next few minutes, we're going to break down the absolute bedrock of calculus. Getting this right is your first and most important step to locking in those 35 marks. Think about it. Everything else that sounds complicated, applications of derivatives, integrals, the whole shebang, it all comes back to these two core ideas you see right here. The bottom line is, if you deeply understand these two concepts, you've basically got the key to the whole kingdom. All right, let's kick things off with our first big idea, continuity. And before we get into any scary-looking formulas, I just want you to get the main idea, which is actually super simple and easy to picture. This is the simplest way to think about it, and honestly, it's brilliant. Just imagine an unbroken, flowing line. No gaps, no jumps, no weird holes. If you can trace the whole thing in one single motion, well, it's continuous. It's really that simple. Okay, but here's the thing. You can't exactly write, "I didn't lift my pen" on your exam paper, right? So how do we turn this simple picture into actual math that's going to get you full marks? This is it. This is your three-step checklist for the exam. For a function to be continuous at some point A, three things have to be true. First, the function has to actually exist at that point. Second, the limit as you get closer and closer to that point has to exist. And third, and this is the big one, those two things have to be exactly the same. So let's boil all of that down to the one thing you absolutely need to remember. This is the key. The limit from the left has to equal the limit from the right, and both of them have to equal the actual value of the function right at that spot. If those three things match up, boom, your function is continuous. Okay, on to pillar number 2, differentiation. Now, if continuity means a graph is unbroken, you can think of differentiation as a level up. It means the graph isn't just unbroken, it's also smooth. Think of it like this: a smooth, flowing river versus a sharp, jagged mountain peak. You could trace both of them without lifting your pen, so they're both continuous, but only the river is smooth. A differentiable function in calculus is just like that river. No sharp corners, no sudden changes in direction. So what does smooth actually mean in math terms? It means that at any point you pick on the curve, you can draw exactly one tangent line. You know, that one line that just kisses the curve at that spot and shows you its slope. But at a sharp corner, forget it. You could draw a ton of different lines, so there's no single unique slope. And that's the problem. So, you know the drill by now. How do we prove this whole smoothness idea in an exam? What's the formal rule that's going to get us the marks? And it's actually pretty simple. Just like we had left and right-hand limits for continuity, we have a left-hand derivative and a right-hand derivative. This is basically the slope of the curve as you come in from the left and the slope as you come in from the right. For the curve to be smooth at that point, those two slopes have to be identical. That's it. All right, pay close attention here, because this is where it all comes together. We're going to connect these two big ideas, and trust me, understanding this relationship is a classic exam question, so you'll want to get this. This is a golden rule, and it's a one-way street. If a function is smooth, meaning it's differentiable, then it has to be unbroken, meaning it's continuous. You just can't draw a smooth curve that suddenly has a gap in it. It doesn't make sense, right? But, and this is the million-dollar question, does it work the other way around? Just because a curve is unbroken, does that automatically mean it's also smooth? The answer to this is what really separates the two concepts. And this picture shows you the answer perfectly. On the left, you've got a parabola. It's smooth, it's unbroken, no problems. It's both continuous and differentiable. But on the right, we have the absolute value function. You see that V shape? You can draw it in one go, so yeah, it's continuous. But that sharp point at the bottom,
That's a huge red flag.
So let's get into the why. Why does it fail the test? Well, think about the slope. To the left of 0, the line is going down, right? The slope is -1. That's your left-hand derivative. To the right of 0, the line is going up. The slope is +1. That's your right-hand derivative. Now, is -1 equal to +1? Nope, not even close. And that's why it's not differentiable right there at x equals 0.
Okay, so now that you have this solid understanding of what it means to be unbroken and what it means to be smooth, let's see how this opens up the rest of calculus for you. Just take a look at all these heavy hitters, every single one of them. I'm talking Rolle's theorem, Lagrange's theorem, integrals, differential equations. They all start with the same condition. The function has to be continuous and differentiable. You literally can't even start the problem without this foundation. And that brings us right back where we started, that number 35. Getting these two ideas isn't just about passing one chapter. It's about getting the master key that unlocks the biggest, most important unit in your entire math exam. So there you have it. The strategy is simple. The ideas are clear. You literally have the keys to those 35 marks right now. The only question left is, what are you going to do with them? It's time to put this into practice. You've got this.